Hey guys, so today we're going to do a video about how to solve any limit. This is any finite limit, which means any limit that's going to a number such as like 0, 5, 20, just as long as it's not infinity. I'll have another video full of examples on about how to do limits at infinity and stuff. So this is just for any finite limit, and there's pretty much 4 steps as you can see here. And this is what you should try every time you get a limit problem. First, substitute, plug in the value. So just plug in for, if the limit as x approaches 1, plug in 1 for all the x's and see what happens. Then if you get an indeterminate form, go to the next step. So then you can try factoring. If it's possible to factor, give that a go. Next, if you can't factor, try to find a common denominator. If there's like a fraction in the numerator, a fraction in the denominator. And then another option is to expand parentheses. So we'll have examples with that, and I'll show you what I mean there. Then another common one that you see quite a bit is where you have to rationalize by multiplying by a conjugate. This is oftentimes when you see a square root in the numerator or the denominator, you might want to go instantly to step 4 after trying to substitute, because you're probably going to have to rationalize by multiplying by a conjugate. And now we're going to go through 5 examples, and each one we're going to have to try all of these different things and see which one works best. Alright, so now let's go to example 1. First step, every time, just substitute and see what happens. Okay, so x is 1, so we're going to substitute. We're going to say lim as x approaches 1 equals 7 plus 4 times 1 plus 12 times 1 squared divided by negative 3 times 1 to the 5th plus 4 times 1. And let's see what that gives us. On the top, we're going to have 7 plus 4 plus 12. On the bottom, we're going to have negative 3 plus 4. So that's going to give us 7 plus 4 is 11, plus 12 is 23, divided by negative 3 plus 4 should be 1. So the limit as x approaches 1, that gave us an answer. It's not an indeterminate form, so we don't have to go on to any of the harder steps. That's just our answer right there. So we didn't have to factor, we didn't have to do anything tough, we just found our answer quickly. So this is best case scenario. This is what you want them all to be like, but sadly, most of them won't be. But that's the way to start every time, substitute. Alright, so here we've got another example. Limit as x approaches 3 of this function. So first step, as always, is to substitute, see what we can get. So we're going to get 3 squared minus 3 minus 6 over 3 times 3 squared minus 9 times 3. And let's see what that equals. On the numerator, we're going to have 9 minus 3 minus 6. That's not looking good. On the denominator, we're going to have 3 squared, which is 9 times 3. So 3 times 9, all right, minus 9 times 3. That's not looking good either. And that's going to simplify to 0 over 0. This is what we call indeterminate form. And what that means, when you see an indeterminate form, when you see 0 over 0 or something, just say in your head, you got to try more stuff. The limit is not 0 necessarily. You just got to keep going and find out some other way to simplify the function. Try more stuff. If you see indeterminate, you got to do something else. Then step 2, we said, was factor. So let's try to factor this. It looks pretty factorable to me, so that's good. So I'm going to rewrite it in hopefully factored form. So let's factor the top. It's going to be x minus 3 multiplied by x plus 2. Then on the bottom, let's see what we can do. It looks like we can take out a 3x, so that's what I'm going to do. 3x, and I'm going to be left with x minus 3. That's looking really promising. And then what you can do is you can cross out your factors, just like always. Factors in common, and we're left with an x plus 2 divided by a 3x. Then we can substitute our x again, and now we're going to be left with 3 plus 2 divided by 3 times 3. And that equals 5 over 9. So the limit as x approaches 3, equals 5 over 9. So we went through our steps again. Our substitution didn't work. We got an indeterminate. So then our next step, as written in the first set, was to factor. We tried that, and it worked perfectly. So that's it. Now we're on our third example. First step, same thing as always. This is a weird looking one. We're not going to see, these aren't too common, but they will show up sometimes, so it's good to know how to do it. So first step, as always, is to plug it in, see what we can get. Limit as x approaches 0. we're going to be 4 times negative 5 plus 0 squared minus 100 over 0. And that's going to simplify to, well, it's going to be negative 5 squared, which is 25 times 4. So I'll just write 4 times 25 minus 100. That looks like it's going to be 0 divided by 0. We get 0 over 0. Same thing, I'll just write ID for indeterminate. So that means we've got to do something else. And our next step is to factor. But it doesn't look like we can factor anything. We actually can't. So, well, our third step, well, let's see what it said exactly. We got to get a common denominator or expand parentheses. Well, I don't think we can get a common denominator, but it looks like we can expand these parentheses. So let's try that out. See if that yields any results. So limit as x approaches 0, and we've got 4. Now we're going to expand negative 5 plus x. So negative 5 plus x, and we're going to have to FOIL this, negative 5 plus x. Let's put this in brackets so it's clear. Minus 100, and still going to be over x. So I'm going to FOIL. I'll FOIL over here, negative 5 plus x, negative 5 plus x. See what we get. It's going to be 25 minus 5x minus 5x plus x squared. We can simplify this to 25 minus 10x plus x squared. So let's plug that back into our function. Run out of space here a little bit. So limit as x approaches 0. And now we've got 4 times, it's going to be 25 minus 10x plus x squared minus 100. Still all over x. So that doesn't look like it's helped much yet. But what we haven't done is, after we've expanded these parentheses, let's try to distribute this out and see if that helps. So distributing out that 4, let me bring this up here. When we bring out that 4, we're going to be left with 100 minus 40x plus 4x squared minus 100. Still all over x. But what I see now is that we've got 100 minus 100. That can cancel. So we're left with negative 40x plus 4x squared divided by x. And this is still the limit as x approaches 0. Okay, and now here it looks like, well, we can factor something out, because in the end we want to cancel something. If we plugged in 0 right now, we'd be left with still 0 over 0, still indeterminate form. So now that we're at this point, let's go through our steps again. We just tried substitution, we got 0 over 0. So our next step is factor. So let me erase this, give myself some real estate. So we're going to factor out, and we can factor out an x from the top. So limit as x approaches 0, and we can say x and then minus 40 plus 4x divided by x, and this is something that we know how to do. We can cancel these out, and now we can say limit as x approaches 0, and we're left with negative 40 plus 4x. And then now we have another new form, so we can start at the top of our steps again, try substitution. Let's see what we get. We're going to get negative 40 plus 4 times 0. That's looking good. 4 times 0 is just 0, so the limit as x approaches 0 is just our negative 40. Yep, that's it. So I hope that made sense. So we went through our steps again. We couldn't factor, so we went to the expansion, and then once we expanded, we had to go back and start all over again, and then eventually factoring is what led us to the right answer. So just make sure you go through the steps each time and keep trying until you get rid of this indeterminate form that we also had over here after plugging in. This was ID again. So then we had to factor, and that led us finally to a real number answer, which in this case was, let me write that a little bit better, negative 40. Alright, now our fourth example. This one, it's pretty clear that we're going to have to do something with those denominators, but again, just for the sake of our time, let's keep everything the same. Limit as x approaches 0, and we're going to again plug stuff in, see what we get. We're going to get 1 over 6 minus 0, minus 1/6 divided by 0. That's going to be 1 over 6 minus 1/6 divided by 0, which equals 0 over 0. Indeterminate. Got to try something else. Step 2 is to factor. Don't think we can factor anything here. Step 3 is to expand parentheses. Don't think we can do that, but it also is to find a common denominator. That looks like something we can do right here with the 6 minus x and 6. Let's try to find a common denominator with that and see what we can do from there. So it looks like this one, the function on the left is going to need to be multiplied by a 6. So we're going to have 6 over 6 times the 1 over 6 minus x. Then the function on the right is going to need to be multiplied by the 6 minus x. So 6 minus x divided by 6 minus x. Alright, now let's see what we get from that. We're going to get 6 over the common denominator of 6 times 6 minus x. And then we're going to be minus, it's going to be 6 minus x divided by that common denominator of 6 times 6 minus x. We can simplify it a step further. We're going to get, let's make it one fraction here. We're going to have 6 minus, make sure you keep these together, the 6 minus x, because both of them are affected by that minus sign, divided by 6 times 6 minus x. And we're still all over the just x. Okay. So now what I can do here is I can fix this top and do like distribute the negative sign, I should say, not factor. Distribute the negative sign. I'm going to get 6 minus 6 plus x divided by 6 times 6 minus x. Still all over this x. And now let me work down here a little bit. We're going to be left with a limit as x approaches 0. Well, we did 6 minus 6, so that's going to be 0. We're just going to have x over, and now let's distribute that 6 just for the sake of time. We're going to get 36 minus 6x, all still divided by an x. Now it's looking a little bit better. We've simplified it a little bit, but our problem is that we've still got this x on the bottom, so we're still not going to be able to get an answer. But what we can do to get rid of that x is multiply by 1 over x, by top and bottom by 1 over x. And let's see what that yields. We're going to have on the top, we're going to have still x. Then on the bottom, we're going to be left with 36x minus 6x squared. Well, I should just leave it actually. X will be on the top, then we'll have x times 36 minus 6x. I distributed it too early. And then on the bottom, we have x times 1 over x, which just equals 1. So it's pretty much not there. We don't need to write that because it's implied. And then now it looks like something that we can factor. Again, when we factor, we just want to cancel something out. So we can cancel, and we're left with 1 over 36 minus 6x. And now we can plug it in. We can plug in our limit. So we got limit as x approaches 0 of 1 over 36 minus 6x. So that's going to equal, well, we'll have 1 over 36 minus 6 times 0, which is 0. So the limit as x approaches 0 is finally, after all that work, we figured it out to be 1 over 36. That's the answer. So that was, again, step 4. We had to do something. This is something you won't see that much, but occasionally you will, so it's good to know how to do it. This is finding a common denominator, and that helps us find the limit. So that's a lot of work. Then now we have one last example. Let me go up. I'm running out of space on the bottom. Let me erase all this really fast and put my new problem up. That looks good. Delete. Alright, there we go. And now let me paste. This is the new problem. Just paste it in the middle of everything. But here we go. Alright, 5. So again, step 1, always the same. Plug in our values, see what we get. Let me get my pen back. We've got x limit as x approaches 6. We've got 6 minus square root of 4 times 6 plus 12 divided by 6 minus 6. Looking like we're going to have an indeterminate here. So we've got 6 minus square root of 36, because it's going to be 24 plus 12, divided by 0, which equals 0 over 0, because square root of 36 is 6. And this is our indeterminate. Try more stuff. Factoring is the next step. Can we factor? Well, it doesn't really look like it. The next step is to find common denominators or expand parentheses. I don't see that here either. So finally we have to use our last step, which is rationalize by multiplying by a conjugate. And remember, conjugates are always, you always use the square root for that. So in this case, we have the square root on the top, and the conjugate is multiplied. When we multiply the conjugate, what we are doing right here, let me show you. We have 6 minus square root of 4x plus 12 divided by 6 minus x. We're going to multiply the numerator and the denominator by 6 plus 4x plus 12. What this is going to do is it's going to get rid of the square root, which is really what's making this problem hard. If we get rid of that, we can solve it. So when you see a radical, you're probably going to have to multiply by the conjugate. That's just a good way to think, and you can really jump to this step earlier if you want to. So let's expand it. On the top, we're going to have 36. Then if you see it, it's going to be minus 6 of the square root, and then it's going to be plus 6 of the square root. So that's going to cancel. That's the whole purpose of multiplying by the conjugate. Whenever you're doing this, make sure you get rid of the radical, because that's what the whole purpose is. So then we're going to be minus, and then it's going to be this one, which is square root times square root, which is just 4x plus 12. They just remove the square roots. Then be careful here. We have to make sure we keep the minus out front, because it has to be distributed to both the 4x and the 12. Okay, and then we have this divided by, and let's leave this in unfactored form. Let's leave it as 6 minus x and 6 plus square root of 4x plus 12. All right, so now let's see what we can do here. We've got, let me distribute this out, this negative out. We got 36 minus 4x minus 12. So what that equals is, let me rewrite this down here, get more space. So right now we're at limit as x approaches 6 of 36 minus 12, which is 24 minus 4x divided by 6 minus x times 6 plus square root of 4x plus 12. And now this part, it can be tough sometimes, because again, if we plugged in 6 again, would be the 24 minus 6 times 4 is 0. Then again, we'd have 0 on the denominator. So really, it seems like we didn't do anything to help, but in fact we did. What we can do now is go to step 2, which is to factor. The bottom looks like it's already been factored, so what can we do to the top? Well, we can factor out a 4, so let's try to do that and see if that yields anything. So take out a 4, we're going to be left with 6 minus x over 6 minus x times square root, 6 plus the square root of 4x plus 12. And that looks a lot better to me now, because we can cancel out these factors again. And now we are left with 4, well, I'll write limit as x approaches 6 of 4 divided by 6 plus square root of 4x plus 12. Now we can plug and chug, plug in our 6. We're going to get limit as x approaches 6. And it's going to be 4 divided by 6 plus square root of 24 plus 12, which is 36, equals 4 over 12, which can be simplified finally to 1 divided by 3. So the limit as x approaches 6 is 1/3. So again, that was the final example. That's when you have to multiply by the conjugate. I hope this video was really helpful. This is the process I use for all my limits now. So substitute, that's the first step every time. Then try to factor, get a common denominator, expand parentheses. Then finally, rationalize by multiplying by a conjugate. I hope this was able to help. Let me know if you have any questions. I'll be coming out with another video soon about infinite limits. Thanks for watching.